All right, guys, let's dive in. Let's talk about linear functions and discovering slope, shall we? Okay, I wanted to dive in a little bit more to this idea of a function. What a function is, kind of give you that bigger picture before we get into the actual content that we're going to be working with. I think this will help you. So, functions can be broken down into families, meaning, for instance, linear functions, which is what we are going to be looking at. This is going to be our unit. These functions always have an equation of this type of form. Okay, and we can say it equals f of x. We can say it equals y. Remember, that's the same thing. That's the same equation either way. And when we graph that equation, it's always, equations of this form are always going to look like, where is this doing this? Something like that. In other words, a straight line. Absolute value equations, on the other hand, might look something like that. And again, I can write f of x or I can write y. Either one works. It's an absolute value equation because you can see it's got that absolute value. And when this one is graphed, it's going to look something like this. Okay, and those are supposed to be touching. So pretend that my lines were a little better drawn. Like that. You're going to get a V shape of some type. Exponential. This is also, this is, by the way, a set of functions we're also going to look at this semester. And exponential functions look something like this. I could say f of x here. I'm going to say y, just to mix it up. And they look something like this. Okay, some type of curve like that, where it's going to curve up and accelerate and grow. The last one, quadratic. And quadratics are also a function family we're going to learn this semester. So you're really getting a preview of what most of the rest of this semester until December is going to look like. It's going to look like the stuff we're seeing right here. And what makes a quadratic equation quadratic is when your x is squared. And I'll say this one equals f of x, same as y. And what a quadratic looks like is something like this. And I should be putting arrows on the front of each of these guys because these are all lines that continue and go on forever. So when we look at these, there's a simple characteristic that makes each of these what it is. In a linear equation, it's because x is multiplying with something right next to it. So there you go. There's always something multiplying with x, and the x is just a single power x. It's just x times something. This is even true if you wrote something like this. That's still linear because technically, remember, we've got the invisible 1 right there. So it's just an x by itself, an x that's multiplying with any number. It's always going to graph as a line. When you plug in different values for x, you'll get different values for y. And all those points will end up making a line if you graph them. Okay? Absolute values, their characteristic is that their x is always going to be inside of an absolute value bracket. And if we remember, that always makes the value inside of it positive. That's going to create this V shape where you'll never be able to get below a certain point because everything below that is negative on the y-axis. So we're going to get that V shape with all our absolute values. Exponential puts your x variable in the position of being the exponent. So it's some number raised up to the x. And so the number we're actually changing is the exponent. And so if we plugged in 1, we would have 3 to the power of 1. If we plugged in a 2, it would be 3 squared. And that type of graph always makes this curve that goes upward, and it's called exponential. The last type is quadratic, and those are created when the x is squared. And when x is squared, you get this U shape. And notice it's not the same as the absolute value. Absolute value is like a V that comes down and goes straight back up. The quadratic is a U shape that curves, called a parabola. So that's just kind of an example set of various function families you might see, and it's always how the x is set up inside the equation. You can have x by itself, just multiplied. You can have x squared. You can have x as the exponent. You can have x in an absolute value. And there's multiple other things you can do. When you get into Algebra 2 later on, a lot of it is just more of these function families. And you just explore them, you graph them, you just kind of work with them. So let's see if you guys can tell me A, B, C, D. What function family are each of those coming from? Pause the video for a second and then write that out. What is the name of the function family for A, B, C, D? And could you even write out an example graph of each of those, or an equation, a function, that shows what must be happening to x to make that function graph? Go. All right, let's dive in and see. A, we can see is that curved shape, which means A is, I'm going to have to write a lot smaller than that. That curved shape means it's quadratic. Okay, and an example quadratic is anything where x is squared. Once you have that, you're going to get that curved shape. All right, B. You guys remember what B is? That was exponential. And the way you get an exponential curve like that is when you have some number. It can be any whole number, and it's taken to the x power. And that's how you get an exponential curved function. That's that family. C, we've got a straight line. Hopefully we're getting familiar with those because that's what we are doing right now, and we're going to see a lot of those. That's a linear function. Notice the word is right inside of it. It's a line, and that's just x by itself, or x just multiplied with any number. That's always going to create a straight line. And last but not least, D. We've got a giant V shape, which tells us that's an absolute value function. And you get that anytime your x is inside the absolute values symbols. All right. So that's just a little bit more to help us kind of understand how functions work. And if you're not clear yet, no worries. We're going to be spending a lot more time on this. This is not something where at this point I would expect you to have a full understanding. I'm just wanting to expose you a little more day after day into what this idea of a function is so that you eventually have a strong concept as a foundation, and you can build your linears and your exponentials and your quadratics on top of that. All right. Dive in and let's look at linear equations. Okay? So this today, or functions, this today for the rest of the day is us going into our linear functions. So they're all going to be lines. And you notice that I tend to talk about equations and functions interchangeably, because a function is just an equation that's got two variables. It's got x and y. So right now we can see on this graph, we've got a blue graph, this guy here, and we've got kind of a green graph, this guy here. So let's talk about some of the characteristics of these two guys. And remember, before I dive into that this is the x-axis. It's always going left-right, and this is the y-axis. It's always going up and down. This is positive on the y-axis. If you go down below the x-axis, you go into the negative y's. The x-axis goes positive to the right, and it goes negative to the left. Hopefully you guys can see those numbers, like that guy right there says -4. So we can see that the numbers are going to get bigger to the right, smaller to the left on the x-axis, and they're going to go positive as they go up on the y's and negative as they go down. So let's talk a little bit about these lines. We need to be able to discuss the characteristics of lines. And really, since they're straight, they're just a line. The only really different thing about them is how steep they are. Some of them are really steep, some of them seem really flat, some of them are right in the middle. So we need a way to talk about that, to say, hey, this line has this certain steepness, or I can put a number to the steepness of this line. So let's look at that and see if we can figure that out a bit. I notice on this blue line, he crosses right there. And then the next place he crosses is right there. So if I were to want to be able to talk about his steepness, I could say, oh, well, he goes up 1 unit, and then he goes over 1 unit. I notice that. If I want to look at that green guy, I could do the same thing. I could just pick any point on that line and say, well, I notice he crosses the grid points right there, and he crosses right here. And I could keep going. You can pick any of the grid points you want. And I see that he goes down 1, and then he goes over 1. And in fact, he keeps doing that, which is what makes him a line. If it keeps going down 1 over 1, down 1 over 1, it's in a straight line. That's its characteristic, whatever the amount of down and over is. It doesn't have to be 1, 1. Now, I want to point out a couple really important things to start. First, we always count the upward and then the over, okay? Or if it's like the green line, we count downward and then we count over, okay? That's the first important thing I want to point out. Let's see if I can slide my screen up. Okay, good. We'll come back in just a second. This is stuff we want to take notes on. When you count your lines, we will always count up, then over, or we'll count down, then over. Okay? The reason why is it's going to help you keep your numbers straight. You'll see if you can develop this habit, trust me, it's going to be way easier to do calculations later. If you just develop this habit, it keeps the signs straight, it keeps the values and where they go into your line calculation straight. It just makes your life easier. Okay? So we're going to count up then over, or we're going to count down then over. And if you look here, that's how I started both of my calculations when I walked through them. So if I was going to, again, just pick anywhere on this first blue line, if I want to know about this point and this point, I'm going to start with going up and then over. Okay? Now, the next thing we want to point out is notice we always, as you guys see, we're always counting or moving to the right when I do the over. I always go to the right. That's also important because we count to the right just like you read. If I read words, how do I read those? I read left to right. You learned that in first grade. Well, slope is read the same way as you read your words in English. You always read left to right as you count across your slope, okay? Notice we're always going left to right as we read that line. Let's also take that into our notes because that's important. When we go over, it's always to the right. Okay? So that means we are always going to count upward on a line and then over if it's a line going this direction, basically up to the right. And if it's a line going down to the right, then we're always going to count down and then over. And that's always what it'll look like. And if you do that, it's really going to help keep things straight. So now let's look at one other thing here. And I'm going to erase. I think we've gotten a little bit busy here. So let's erase some of this. We'll just add this guy back. If I'm going here and here, notice when I count upward, heading upward, the y's are positive. They're increasing, okay? Now, it's not where I'm at on the graph. Anywhere I count, even if I was counting down here and counting upward at the bottom, even though I'm in the negatives, I'm counting upward, which means my numbers are increasing. Because of that, that's a positive. It's a growth or a change. I'm looking at this line from here to here. And when I move upward and then over, that line has gone up a positive 1 unit. And the same thing when we go over by 1, it's also positive because right here we see the positive x's. When you go to the right, just like we did inequalities the other day, to the right is always increasing. It's always going to the positive. It's growing. So that's going to be up 1, over 1. Both positive numbers. Now let's look at our other line. If I start here and I start here, I'm going to go down. That line's different. That green one is different than the blue one, and we need to have a way to talk about that. He's heading the opposite direction as we look across this page from left to right. And if he's going downward toward the negative y's, downward is going to tell us it's negative. So we're going down or negative 1, but our over is still positive because we're still heading toward the positive x. So it turns out the only time you ever deal with a negative number, anytime you're talking about steepness, is right here. If you've got a line that's going downward, when you count it, the down is a negative number. And so this guy, he's going down 1, which we're going to call a negative 1, and then over 1. Okay? All right, let's take just that concept and see if you guys can apply this so far. Counting on the lines is important. So, there's a couple new lines, and they're going, they've got a different steepness. They're not going straight through up 1 over 1 like the first two were. These have a little bit different steepness. See if you can count, and you can even draw this arrow, or draw this line, into your notes, and then use the, draw some arrows on that line in your notes. And you don't have the grid. If you have graph paper, great. We're going to need to get some for class for you guys to practice this. But for now, you're just counting and you can use my page. So what is the steepness of the purple line? What is the steepness of the blue line? Go ahead and count and write it out. Go. All right, let's see if you're getting this. Now, I'm going to pick anywhere the purple line crosses the grid marks. I could pick this point to start. Maybe you picked that. And then I see the next grid mark is not until here. And the next time it crosses a grid mark is not until here. So you would need to pick one of those three in order to count. Now, I'm always going to count. This line is going upwards as we look across. So this is going to be an up and then over. I'll start here, and I'll count up. I went up 1, and that's positive since I went up. And then I went over 1, 2, 3. And that's always positive. So it turns out that purple line was going up 1 over 3. All right, let's look at the blue line. He's crossing the grid here. He's crossing the grid right in the middle. They cross at that point, and he's crossing here. So those are the only three places you can work with him. I'll start in the middle this time. I can start on any of those, but I'll start in the middle. And at this point, remember, since it's going downward as we look across left to right, I'm going to go down to start. How far did I go? I went down 2. And because I went downward, it's negative. That's important. You really want to grab onto that, see that, and hold on to that. Downward 2 means he's negative. And then I went over 1. And the over is always positive. So what happened with that blue line? He went down 2, over 1, and that 2, when it's downward, means it's a negative 2. All right, let's have you guys try and do this. Here's the first part of your homework. Part 1, identify each function family and write an example function for it. So just like we did before with examples. A, B, C, D, what are the names of those types of functions? And give me an example function which shows the characteristic that x has to make that type of graph. Remember, we've got x by itself, or x raised to as an exponent, or x raised to a specific exponent. So write those out. And then when you're done with this, the next page here, here is part 2. Write out the steepness of each line. You got A, B, C, 3 lines, and I want to point out real quick. Notice you want to make sure you're looking at where your line crosses grid marks. It's not crossing the grid mark there. You can't use that. You can't use that. None of those are grid mark points. You have to use where it crosses an X and a Y, okay? So you would count between those 2 points if you want. And then you can keep going and see that down here. Okay, may have just had a snafu, but I'm back. I noticed I had to move things so you could see that final point where line A crosses a grid. So make sure you're using where they cross the grid points, and then you're just going to be telling me it's up 1 over 3 or down 2 over 4, and make sure to note when that's a negative number. All right? Peace out. See you guys tomorrow.